In this lecture, I will explain you how to draw NFA in a systematic way. For that, I will take this example W, where third symbol from right is 1. We have seen how to draw DFA, and you remember the design was quite complex, right? Now we are going to design NFA, and the design will be very simple. Now we'll learn it. So the strings which satisfy the condition are these two, you see 101, third symbol from right is 1, third symbol from right is 1. So we have to design our machine such a way that it accepts all such strings. Now let us begin. First I draw an assistant machine. What it will do is, so it will be called, like imagine like a programming, it will be called whenever there is, on third symbol, right? Okay, if that is the case, what is going to happen, we'll see. So if this is the third symbol, then only it will be called. Then Q3 will remember that the previously seen symbol is third symbol. Then on 0 or 1, because the second symbol can be anything, that's why on 0 and 1 you go to same state, or 0 or 1 go to same state. You see this one? This is the final state. Okay. Now example, let's say 101. You see it works 101, 110, 110. That means if really Q3 is called on the third symbol, then everything will work smoothly, right? Now we'll try to use this assistant. So this assistant has one more property you should understand. If you give him a wrong string, that means 1100, you see. That means if you call him on fourth symbol, what is going to happen? He designed for third symbol, right? If you design, if you call for fourth symbol, what is going to happen? On 1 he will come to Q3, then on 1 he will come to Q2, on 0 he will come to Q1, but there is another 0, then he doesn't know what to do. Yes, we planned it such a way that the right string will be accepted and the wrong string will be rejected. So far it's good, but only assumption so far we have, that is how to call him at right time. The problem with your machine finite automata is at any point of time you don't have a clue which one is the third symbol, which one is the second symbol, in that way, because we are reading from the left side, correct? So that's why. So the problem is when to call. For that I have a trick now. So I initially will be at some start state. Okay, let's call it as Q, and whenever a 0 comes, then I don't call this assistant. This is an assistant. On 0 I don't call, because the pattern is all about 1, right? Having 1 at the third symbol. So that's why on 0 I will stay it here. Now whenever a 1 comes, then I will call, but still it will not work, right? Because you are calling your assistant at wrong time. Example, that is what we discussed already, 1101. Then if you call on this one, then he will try to accept it, but he cannot, and he will reject. But now you see your machine is dead. That means now the execution sequence begins at Q. So Q on 1 we are going to Q3. This is called a control. So control was at Q and it is coming to Q3. I am using various terms, so try to understand them. Then again on 1 control goes to Q2. On Q2 the control goes to 0. Q2 on 0 the control goes to Q1. Q1 on 1, so there is nothing defined, so that's why it will go to empty. That means your execution sequence is terminated. So what, sir? See, actually if your execution sequence is terminated, then who will detect the pattern, right? We have to detect the pattern. But why your assistant cannot detect the pattern? Because he is wrongly called, right? He should be called here, but same time your overall machine doesn't have any clue when to call this assistant, correct? That's a problem we have to solve. That is all about NFA. In NFA, that's why what I do is, so your execution sequence, all the execution sequences should not be dead before detecting the pattern. That's why on 1 I will be at Q. On 1 I am calling assistant, at the same time I will keep one copy alive at Q. So what happens, we'll see. Because of that, so this execution sequence will be terminated. I am showing here Q on 1. There are 2 threads now. So one is your assistant thread, second one your main thread, which is at Q. Now you know that eventually it will be dead, already we have seen. Now when you are at Q, again you are reading 101, you know the logic. Whenever you are here, and always again you will call your assistant on 1. That means now next time you can call your assistant again only when you are at Q state. That's why this method will work. So what I am saying is, when you are at Q, when you read this 101, then you will definitely call your assistant, then he will eventually go to final state. Okay, let me show this entire process clearly. So what I am saying is, initially you are at Q, and when you read 1, then you will go to Q3, then you call your assistant, and on 1 you will stay at Q, correct? Now you know I am not talking about this thread because you know this will fail miserably. Now when you are at Q, then the remaining input you have to read is 101, the next symbol is 1, again assistant will be called, that's a trick. Then on 1 again will stay back, and this is for being safe, that means to be alive, so that next time again we can call our assistant. So Q on 1, Q3, then I will show the remaining thing. Q3 on next input is what? 0, then both threads will execute that 0 input, then Q3 on 0 we will go to where? Q2, and Q on 0 we will come at Q. Now after that, one more symbol, Q2 on 1 it will go to Q1, that means see, your assistant is working properly. Now this will fail, no problem, let it fail. So Q1 on 1, again you will guess that 1 is at Q, that means again we'll call assistant. So who is assistant? Q3. Sir, why are you calling it again? Because we do not know. If we know, we do not have a clue that which one is the right symbol. That's why we are calling every time. So one of them will be successful. Who is successful fellow? Here, this fellow, right? So that's why I can say that there is an execution sequence which eventually went to final state. That's why. So NFA accepts this string. That is the way it is defined. Fine.